Hey guys, hello everyone. Welcome to the Sun Academy, all of you. So guys, as you know that your CSR UGC NET examination, which was December 2022 and June 2023 combined examination had taken place on 7th of June. All right. And guys, ये जो exam हुआ था इसकी answer की भी बहुत जल्दी आ गई थी. It's like the answer key was out like within 7 to 8 days of the exam, which is very good because now you have proper solutions, proper answer keys to your question, and we are trying to discuss some of the solutions, some of the proper answers to those questions. So here in this particular video we are going to be discussing detailed solution to the organic and inorganic questions. And about the physical chemistry part, you can see that in the video on the All About Chemistry channel, that is Nurul Huda sir's channel, and you can watch that video for physical chemistry. Also informing you all guys that we have a combined batch course on Unacademy, and I will tell you a little bit more about it in detail later on, but first let's start solving questions. Okay. So here you go. We are starting with section B questions and then we move onwards to section C questions. Also guys, बहुत सारे questions. It's around more than 40 questions. So we are going to be discussing this very fast. Okay. So yeah, first one. Considering nitrogen as a central atom, the structure of these two respectively are. So this is a very basic question from chemical bonding which came this time. And it's a very basic question around IIT JEE level, क्योंकि वहां पे भी सब लोग ये पढ़ते हैं कि nitrogen, why is the nitrogen going to give you a difference in structure based on the carbon and silicon? Only that is the difference in both of these. So carbon does not have a vacant d orbital, however silicon has a vacant d orbital in this way. All right, and that's why the lone pair which still exists on the nitrogen could be involved into resonance because of the vacant d orbital of silicon, and that's why it has to be linear. And since there is no occupancy for this lone pair into the methyl, that's why it's going to be bent. So correct answer is first one, bent and linear. Okay. Next question. The electron impact mass spectrum of this particular compound will show a base peak at m by z value of. Now this exact question has come in GATE, I guess 2014 or 15, I don't remember the year, but this is a question which was asked in GATE examination before. So that's why we always say that practicing previous year questions will be very good for all of you. Okay, तो इस molecule को हम ऐसे लिखते हैं. Why do we write it like this? Because we want to carry out McLafferty rearrangement. Mass spectrum में भी कुछ ही गिने चुने fragmentations है, which if you do is going to be really great. McLafferty is one of them, most popular one. So we always consider a radical cation first of all, that is the molecular ion peak. Okay, and that is going to pick out a gamma hydrogen. So let's give the numbering alpha, beta and gamma. So ये gamma hydrogen है. So gamma hydrogen is going to be removed. You are going to get this kind of a double bond over here, NH. Alright, there is a radical and there is one positive charge. Okay, because this radical has combined with this hydrogen and the positive comes on the carbon. Now alpha beta cleavage will take place in this way such that you get a double bond in between these two CH2 and you get an alkene. Alkene elimination और इसके साथ ही साथ क्या मिलेगा? CH2, one radical, C पे positive and double bond NH. Now you have to count the mass of this fragment. Be careful, this carbon did not have any other species, no hydrogen is present over here. So count the mass like this, 14 plus 12 plus for nitrogen 15, for hydrogen one more 16. If you count it in this way, you will find out you are going to have 41 mass. Alright, so what did we do? For nitrogen we count 14 and for one hydrogen it will be 15. So 14 plus 1, 15. Okay. So yes, now it's going to be 41. Answer is option number 3. Next question, easy one. For the radicals A, B and C, ये पूरा GOC का question है guys. Correct order for the relative rates of addition to this particular complex is. Now if a radical is going to add to this kind of a species. How the addition is like, it's more like a conjugate addition, isn't it? Yes. So relative rates of addition. Who is going to react the fastest? Who is going to react the slowest? That is the question. तो हम इनका structure देख लेते हैं. The methyl radical over here, A, is like this. CH3, CH2, secondary radical B. And yes, what about this one? C6H11. Looks like it is a cyclohexyl radical. Alright, because then only per carbon you will have two hydrogens. Okay. So this is what you have. Now, which is the most stable radical? This is the most stable radical. Most stable radical is going to do conjugate addition from over here. Alright. So to this alkene which has an electron withdrawing group, this kind of attack will take place better with the most stable alkene. So this is the order option number 2. Okay. Moving onwards to next important question. देखो guys, if you have noticed in the previous year questions, एक time पे Hammett equation बहुत popular हुआ था. That is, Hammett equation was asked in almost every examination, almost next exam, like GATE and CSIR, everywhere. And recently this kinetic isotopic effect has become popular. So it can be asked in the next exam also. All you have to do is, you have to study this from chapter number 39 of Claydon. क्योंकि ये chapter जो है, it is about determining reaction mechanism, that what are the methods of determining the reaction mechanism, कि ये सही है कि ये गलत है. Okay, so that is very very important. Now let's talk about this. If you already have an idea about primary kinetic isotope effect, उसमें ऐसा होता है कि the rate constant of a reaction in which a carbon hydrogen bond is breaking divided by Kd is going to be greater than equals to 7. Approximately that, ki when we have a huge difference of rate constant when a proton is breaking and when a deuterium is breaking, if there is a huge difference, then we can say it is having an isotopic effect. But for that, the carbon hydrogen bond breaking must be involved in the rate determining step. तो आपको यही check करना है, is it in the rate determining step or not? If not, then no isotope effect. So option number A, we check this. What is this reaction, guys? It's a 3,3 sigma tropic rearrangement reaction. So in the 3,3 sigma tropic reaction, which is a concerted process, one step process, so that is only going to be the rate determining step, like this one. And later on, the proton is falling off and shifting again. So ये जो proton fall or shift है, that is a fast step, and the 3,3 sigma tropic one, this is the slow step. So the OH, this proton falling from here and attaching with this oxygen is not in the rate determining step. Okay. Option number B check करते हैं once again. What is this reaction? It is a ring opening reaction. See, it is a ring opening reaction like this. So definitely the hydrogen is not breaking at all. So it's not going to show you kinetic isotopic effect, at least not the primary one. Third one, here you have something different. Why? Because here it is a beta keto acid, and let's write the beta keto acid in this way. Because now you see it is involved in some mechanism. Dekho, when we are heating this, removing carbon dioxide, we are going to write a 6-membered transition state in this way. Alright, we are going to write the 6-membered transition state which gives you the enol. So it can tautomerize back to give you the ketone, but chalo theek hai, enol tak hi likha hua hai. Is the proton involved in the rate determining step? Yes, absolutely. So only C is going to show you the kinetic isotope effect. You can study more about this in the books. Okay. Next important question, the proton NMR spectrum of a mixture of chloroform CHCl3 and acetone CH3 C double bond OCH3 shows two singlets, remember that, no splitting, at 7.25 and 2.1 ppm respectively. So this is going to show you 7.25 and this is going to show you 2.1. Definitely, because there are 3 chlorines connected. So this is very de-shielded proton. Now this is actually of no importance to us. इस value का कोई भी काम नहीं है इस question में, because we only need this value. The integral heights of 12 and 18. So this is of a greater height, this is of 12 height. Now if the height ratio is 12 is to 18, the molar ratio of chloroform to acetone in the mixture is. Now you see that you have only one hydrogen, एक hydrogen है उसको 12 करने के लिए किससे multiply करना पड़ेगा, one hydrogen multiply by 12 to give you the 12 integral height. Okay. However, here you have 6 hydrogens. So 6 को किससे multiply करेंगे such that you get 18. You are going to multiply 6 hydrogens with 3. So you are having 12 moles of chloroform and you are having 3 moles of acetone. Okay, and let's write the ratio. 12 moles is to 3 moles is going to give you 4 is to 1. So this is the molar ratio. This is the correct answer. All right. Moving onwards, according to Huckel's rule, again a very simple question. M and N are aromatic or non-aromatic or anti-aromatic. Let's see. So guys, boron, as you have already seen this in carboboranes as well, where while we are counting the electron, one boron is equivalent to a carbocation, isn't it? The number of electrons and one vacant orbital is present. So these two are equivalent. Okay? So we will just introduce the lone pair into boron such that you can write a similar structure to naphthalene. Although the structure is similar to naphthalene, there are going to be some differences. That is, this bond is actually more localized as compared to delocalized. Okay, because it's on nitrogen and boron like this. This bond is more localized, but still there is a ring current and it is following the Huckel's rule. So it is going to be aromatic. Okay. Similarly, as I said, the boron equivalent to a carbocation. So here it is equivalent to the tropylium carbocation, which is like this. So even the tropylium carbocation is aromatic. This is also aromatic, and boron has a vacant p orbital in which the pi bonds can do resonance. So both of these are aromatic, right? 2 is the correct answer. Next very important question. I have just explained this in my plus classes that why AgF is the answer to this question. See, the silver salt with the highest solubility product in water is. Where is this question coming from? This is coming from ionic bond in chemical bonding topic, and you must know Fajan's rule for this. What does the Fajan's rule say? Fajan's rule, see, the sorry, the solubility of any particular molecule or any ionic compound depends on two things. First is the lattice energy, and second is the hydration energy. So the hydration energy is going to be actually higher for the smaller cations because cations and anions both, because they are compact and greater hydration because of that. But for the lattice energy, we need to understand the Fajan's rule application, that if the cation is small and if the anion is big, just like a Ag plus and a I minus, for example, then this Ag plus is going to be able to pull the electron density and distort the shape of I minus, and because of that the lattice energy decreases. Okay, so ma'am, आप तो ऐसे बोल रहे हो that lattice energy is going to be less for AgI. Alright, I am writing the order of lattice energy. AgI has less lattice energy than AgBr, then AgCl, then AgF. Alright, but still, so according to this question, AgF should have maximum or let's say minimum solubility, क्योंकि lattice energy तो बहुत high है AgF की. नहीं, ये usually जो ये order है ये follow होता है for the sodium chloride and so on. The order of lattice energy will not be followed over here the same, because here we are talking about polarization as well. In the compounds of silver, we have polarization, which is the dominating factor. दो type के compounds है, एक तो simple S block elements and एक silver, because silver is going to be having a greater covalent character. So what is the covalent character property? Covalent character is going to be maximum in AgI, and then AgBr, and then AgCl, and lastly AgF. So AgF is most ionic, and that's why it's most soluble in water. So what is the determining factor over here? Polarization. Polarization is the most important factor which determines the answer, particularly for silver salts. So 3 is the answer. Next question. In the gas phase, the correct order of hydride affinity for the given carbocation is. अच्छा, तो ये question ऐसे भी put कर सकते थे. What is the order of hydride affinity, or let's say who is going to attract H minus the most? Why are they giving the gas phase? What is the relevance of the gas phase? So in the gas phase, you don't have any solvent interaction. There is no hydration. There is no hydration sphere. And that's why it will consider gas phase, where only the hydride will be attracted based on the molecule's attracting power, nothing else. Okay. So yes. So what do we see? That this is the most stable one. This carbocation is most stable, and that's why it does not want a hydride. This is also stable. This is 3 degree. This is the most unstable. And that's why it is going to need the hydride maximum. Okay. So C greater than B greater than A is the very simple answer that you have for the hydride affinity. And the question is a GOC question which is directly asking you the order of stability of carbocations, nothing else. Okay, next question. Number of oxygen atoms bonded to each phosphorus center in P4O6 and P4O10. So guys, you are going to draw the structure in adamantine way because it's the best way you can, understand the structure. Alternate position पे phosphorus, oxygen, like this. Now this is for P4O6. P4O6 में आपने देखा है each phosphorus is connected to 3 oxygen atoms. Alright? Each phosphorus center in P4O6 is connected to 3 oxygen atoms. 1, 2, 3. ये अलग phosphorus है, so 1, 2, 3 again. Okay. Now for P4O10, we are just going to write double bonds on each phosphorus. So this is connected to one more carbon. So P is connected to 4 oxygens in P4O10. So 3 and 4 is the answer. Very simple. Next question. Based on the given data on the first order rate constant for the following reaction, the correct statement is. Now see this, guys. The data is already given to you. That is, if X is a hydrogen, the rate of reaction is around 4.81. For chlorine, it is lower. तो usually हमें ये expectation होती है that if there is a chlorine over here, it is going to favor the reaction because it is adding in the Markovnikov way. This is going to become CH3. This is CH3 and there is a positive charge. So chlorine is lower than hydrogen. इसका मतलब ये तो है ही नहीं that chlorine is using a mesomeric effect or something. No. Otherwise it could have been higher. तो mesomeric effect use नहीं हो रहा है, not being used. Second effect is inductive effect. So because of minus I effect of chlorine and fluorine, it's going to be destabilized. So guys, do you see this minutely कि अगर minus I effect होता chlorine और fluorine का, then fluoride will be destabilizing the carbocation even more. But why the rate of fluoride is faster? Fluoride and chloride inductively stabilizes. Absolutely rubbish. Not possible. Chloride stabilizes the intermediate carbocation better than hydrogen. If that was the case, the rate of reaction could have been higher, but it is not. So this is also wrong. Cl stabilizes the intermediate carbocation better than fluorine. I don't think so because fluorine is giving the fastest rate of reaction. Fluoride stabilizes better than hydrogen. That is true based on, all of this is based on the set of data that you have. So fluoride is going to do the reaction fastest. And I have a mechanism to explain this very easily, very clearly, that let's say this is your fluoride and it is accepting a proton and it's absolutely going to give you this kind of a carbocation like this. But if we are talking about hyperconjugation, then fluoride is able to do it best. CH2 double bond F, H plus. by hyperconjugation stability or by minus H minus I effect also. It can pull the electron density. Fluorine can pull the electron density from this particular carbon and hydrogen bond. However, hydrogen and chlorine are not successful in doing so. So, fluorine can only stabilize the carbocation by doing hyperconjugations. And how many hyperconjugation structures are possible? See, the carbocation has 6 hyperconjugation structure possibility. Okay, and the fluorine is maximum, is accepting this electron density from over here, so it's going to be giving you maximum stability in fastest reaction. Very beautiful question. Now next one, the major product formed in the given reaction. So again, this kind of a same question has been asked in GATE exam, although the molecule was different, but yes, there was a toluene molecule which was used. Again, so in the presence of light, we are doing bromination. That is absolutely, first of all, going to give you the more stable radical like this. A carbon-hydrogen bond is going to break homolytically, and it's going to give you this tertiary 3-degree stable carbocation, radical, and then the Br radical is going to attach to it. So that's it, very simple, and you are supposed to form this compound. So as I had informed you guys, this is the Warriors batch, that is the detailed batch course on chemical sciences. It has already started. We had already started the batch, but the only few topics are done, and it's a new batch for the December 2023 exam preparation. So if any one of you is interested in joining up, then please take care of this till June 17th. There is an offer going on which is around 25% off from the usual discount price, and by applying any of the educators code, you can join up. My code is Jagriti S. So you can join up and study all of these important topics in Unacademy Plus. Now, what are the contents of this course? Organic chemistry, inorganic chemistry, spectroscopy, physical chemistry, everything which is required for the CSIR net preparation. Okay. Now let's move onwards and do a tricky question over here. The number of signals expected for the given compounds in the proton NMR and C13 NMR spectra respectively are. Now in this particular question, you see that there is a sigma plane which is cutting the molecule into half. This sigma plane will cut as the atoms I am marking. It is going to cut, it is going to bisect all of these atoms, okay, and it is going to cut all of these bonds like this, okay. It is like this. Now if we say such things, see guys, ये यहाँ पे hydrogen नहीं है, there is no hydrogen over here, there is one hydrogen over here, and here there are two hydrogens over here on this carbon and two over here. So totally we have 6 hydrogens, and all of these are diastereotopic because you cannot find out any relationship between these hydrogens. So all the 6 hydrogens are diastereotopic in nature. That's why they are going to give you 6 particular distinct signals in proton NMR spectrum. What about the number of carbons? So if you see the number of carbons, you have a sigma plane once again, which is passing through all of these centers. So we have 1, 2, 3, 4, and 5. We have 5 signals for the carbon, and these are going to be repeated as on the front side. So 6 in the proton NMR and 5 in the C13 NMR. Answer is option number 2. Moving onwards to another very simple and tricky question. See, the above reaction involves. Now you can easily fall for this कि ये आपका bimolecular nucleophilic substitution reaction है. You might feel like it is SN2 reaction. Why? Because we have a cyanide. Cyanide ने इधर attack किया और ये तो good leaving group है. It is going to leave. But we are falling for this. Wrong answer. Why? It is definitely a good leaving group which is readily going to leave, which is going to leave very, very fast before your nucleophile can attack over here. Alright, it's a very, very good leaving group. So what happens is the nitrogen is going to assist in the, actually the nitrogen is not kind of pushing it away. The nitrogen is only stabilizing the carbocation which forms after the elimination of this particular group. Okay, and that's why we will say it goes through elimination reaction first because of a good leaving group, and then the cyanide is going to attack. If there was a chloride or if there was iodide or something, then we can think of it of a SN2 reaction, but not with this one and not with this assisting group. When indole is present, it is absolutely going to be elimination followed by nucleophilic addition. First elimination to give you this kind of a system, followed by conjugate cyanide addition to give you the correct answer, this one. So moving onwards, next question. Of the following, correct statement about carboxypeptidase A are. Now, as I had already informed you that most of the statement type of questions will be asked from the bioinorganic section or the main group. Okay, and that is what has happened. बायोइनऑर्गेनिक में ही सबसे ज्यादा ऐसे क्वेश्चंस है जो स्टेटमेंट पे बेस्ड है एंड ऑल ऑफ दीज आर फैक्चुअल क्वेश्चंस. दैट इज इफ यू नो अदरवाइज जस्ट लीव द क्वेश्चन एंड मूव ऑनवर्ड्स, नहीं तो गलत होने के बहुत ज्यादा चांसेस है. राइट, यस. सो अबाउट कार्बोक्सीपेप्टाइडेज ए विच इज एन एंजाइम विच हैज काइंड ऑफ एन एग लाइक शेल. इस तरीके से एक एग लाइक शेल में होता है Zn2+. एक तरफ तो लूजली बाउंड वाटर and on the other side we are having the nitrogen from the histidine. All right, and then on the other side you are having the glutamate residue. This is kind of roughly drawing the structure of this. Two histidine nitrogen atoms and glutamate oxygen atoms. Why atoms? Because glutamate में जो carboxylate होता है उनके दोनों atom connected है. And a water molecule coordinate to Zn2+. So yes, it is. Alright, this is the structure correctly. Zinc 2+ ion acts as a Lewis acid. Yes, it will always act as a Lewis acid. This is correct because that is the nature of a metal. So A and C are correct. Why B and D are wrong? The substitution of zinc 2+ ion by cobalt 2+ ion renders the enzyme inactive. ऐसा नहीं होता है. Both of the metal ions can be used. However, zinc is more preferred, but replacing it with a cobalt does not stop the reaction. So this is wrong. 3 histidine nitrogen atoms in a water molecule. No, where is the glutamate? वही wrong हो गया. Glutamate present है यहाँ पे. So 1 is the correct answer. Next one, another question from main group. X, Y and Z are 3 p block elements in the second row of periodic table. Now, in the September 2022, Feb 2022 also, exams also, you have got the value type question, जिसमें actually values देते हैं. Based on the value, you have to give the trends. So, with electron affinity, so ये electron affinity का value है. The correct statement among the following is X, Y and Z. Y is the has the highest first ionization energy. So let's write it over here. It is so evident that Z is going to be the most electronegative. Yes or no? Because it is having the maximum electron affinity. और यहाँ बोला है second row of the periodic table. What is the second row of the periodic table? In which we are going to have, let's say, the first row is where the hydrogen and the helium is. Second row में कौन रहता है? Lithium, beryllium, boron and so on. Nitrogen, oxygen, fluorine and so onwards. So like that. Now this could be fluorine or it could be oxygen, right? Which means that out of XYZ it is going to be most electronegative. Most electronegative. That is true. And most electronegative one requires the least number of electrons, so it readily accepts. X is going to be most electropositive, and who is going to have the highest ionization energy? Z itself. So Y does not have the highest ionization energy. X has the most number of p electron. No, the same goes for Z. That's why it needs minimum number of electrons for fulfilling its octet. The same, Z is the correct for both. X has the highest proton affinity. The highest proton affinity will be again to the most electronegative. Z has the highest electronegativity. This is correct. So fourth is correct and all the other statements are correct for Z. Okay. So this is the correct answer. Next, among the following, the NMR inactive nucleus is. So you have studied this in the proton NMR, that a nucleus which has both atomic number, let's say this is your nucleus X, both the atomic number Z and the mass number A, both of these, if they are even, if both of them are even, then it is absolutely inactive. हमें क्या चाहिए? Either odd mass चाहिए या odd atomic number चाहिए. So the nuclei should have either odd mass or odd atomic number. Alright, so these are the two necessary conditions. यहाँ पे क्या है? Mass is even, लेकिन atomic number odd है. Here both of these are odd. Here both of these are even. So absolutely magnesium is the one which is inactive. Here the mass number is odd. So well, 3 is the correct answer. It's inactive. Next one, the absolute configuration of the stereogenic centers present in the following molecule is. So, we have done these kind of questions in GATE exam or CSIR previous year exams. All right. How are we going to give the priority? Let's check quickly. Yeah, right. So first of all, guys, we are going to give the first priority to this particular carbon. Let's find for the ninth carbon. Okay. So according to this, we have 1, 2, 3, and 4. Four different groups which are connected to it. The first priority will be given to this carbonyl which is connected to a CH2. Second priority will be to this carbon which is connected to 2 oxygens and 1 hydrogen. Third priority to this particular carbon which is connected to only 1 oxygen and 2 other carbons. And the fourth priority to this CH2. So 1, 2, 3 is clockwise, and since both of the CHO are above, the CHO is above, then definitely this fourth one is below, so it is going to be R. About the 10th one, here if you give the priority, you have one OH and you have these 3 different carbons. How is the priority going to be? One for the oxygen, second is going to be for this carbon which is connected to so many groups, third is going to be here, and fourth is going to be here. It is 1, 2, 3 anti-clockwise, fourth is already below the plane, so it's going to be S. So first one is the correct answer. Okay. Given that the pKa1 and pKa2 value for alanine, now alanine is the smallest amino acid after glycine definitely. That is, it does not have any side chain. अगर इसमें question में थोड़ा सा side chain डाल देते तो थोड़ा difficult तो हो जाता, but it was such an easy question. 2.34 plus 9.68 divide by 2. ठीक है, इतना करने से ही आंसर आ जाता है. And what is the answer? It's going to be 6.01. Very simple. If you have amino acids which are having an acidic side chain or a basic side chain, then that's a little bit tricky. But ये तो बहुत ज़्यादा easy question था. Okay. Now see again, Hammett constant value also asked. So chapter number 39 you have to study from Claydon. Determining reaction mechanism. अभी तक Hammett equation आ गया है. Kinetic isotope effect आ गया है. आगे let's say isotopic labeling experiment bhi aayega, which has also been asked previously. Okay. So the value of Hammett substitution constant for paramethoxy. Alright, so for you know already that for benzoic acid, the constant is taken as 1. That is the standard value. ठीक है. लेकिन जो paramethoxy है, उसकी क्या होगी? Minus 0.30. So if the pKa of benzoic acid is this much, that of para-anisic acid is. Now you don't have to do the mathematical calculation over here. It's only based on logic, and the options make it even more easier. How? You see कि 4.19 जो value है, that is for benzoic acid. Alright, that is for benzoic acid simply. This is तो para-anisic acid. लेकिन ये benzoic acid के लिए है pKa value. ठीक है, PHCOOH. Now, if we say that we are adding the methoxy group, that is going to decrease the acidity and that is going to increase the pKa. How much increase? Addition of 0.30. All right. So addition of this into 4.19 is going to give you 4.49, and that's going to be the answer. All right, ये इसका आंसर 4 है. Okay. Yes, not 3. Absolutely no. It's 4. Because acidity goes on decreasing while we are adding electron donating group or electron withdrawing group लगाएंगे तो definitely decreases. Okay. Next question. A pair of complex ion that does not obey the 18 electron rule is. Now, very, very simple. As soon as you look at this compound, you know it is 17 electron system, right? And it does not even dimerize because of small size of vanadium. ठीक है, ऐसे question आते हैं इसके ऊपर. So, vanadium has how many electrons? 5 plus 12 from the carbonyl, so total of 17 electrons it is. And the titanium one, it has 4 electrons, 10 from the Cp, 2 from the chloride. How much? 16 electrons. So they don't follow the 18 electron rule. However, all the other ones we have seen are going to follow the 18 electron rule. Okay? आप एक बार calculate कर सकते हो मैंगनीज के लिए 7 plus 1 for the bromide plus 10 हो गए 18. Similarly 7 plus 10 and plus 1 for this. So again 18 and so on and so forth. All of these are 18 only. Chalo. Next question. For a transition metal M, the correct order of C13 NMR spectral shift in ppm relative to SiHC, that is the TMS. So ये हमारा standard है TMS. Alright, so this is our standard TMS. Now for a transition metal, the correct order of C13 NMR spectral shift for the moieties over here. So what is a methyl going to do? If a methyl is connected to a metal, metal is more electropositive. Methyl तो ligand है, तो ये तो negative होना चाहिए. Most electron rich. And the carbonyl is not the most electron rich, isn't it? And this is the pH. It also has a ring current of itself. This the pi bond stuff, diamagnetic deshielding की वजह से. So carbonyl is going to have the maximum deshielding, maximum value. Then comes the phenyl group, थोड़ी सी कम value होगी, और methyl तो यहाँ पे negative ligand है, so it's basically the most electron rich. So 1 is the correct answer. Next, the intermediate involved in the given ETARD reaction is. Now you know guys, ETARD reaction बहुत basic level पे पढ़ाया जाता है, ठीक है. And when we talk about reagents, we don't usually follow the mechanism, but हाँ, अगर ऐसा question आ जाए तो वो भी करना पड़ेगा. How does it follow? And you know guys, same question आ सकता है MnO2 के लिए और KMnO4 के लिए for this particular compound. So you must go through the mechanism of that as well. क्या पता अगली बार एग्जाम में आ ही जाए. Okay, yes. And then let's take the CrO2Cl2, that is the chromyl chloride. So oxidation via chromyl chloride is the ETARD reaction. Okay, ये bond अगर इधर fall कर गया, then this is going to attack. Okay, you are going to have a CH2 double bond and one single bond with chlorine, Cl, another Cl and another OH, और एक carbonyl ऐसे का ऐसे रह गया है. Okay, now what is the next step that we are doing? See, the intermediate is going to now, the carbonyl is going to now attack over this CH2. The bond opens from here और ये chromium चला जाएगा यहाँ से. So ultimately you have benzene again. You have bonding with CH2, oxygen के through, and chromium and Cl and one OH. Alright, and there's one more Cl definitely. So you're going to have 2 Cl and 1 OH and 1 oxygen in this way. Now what is the next step? The next step is elimination of HCl. Let's say कि ये H और ये Cl का elimination हो रहा है. Minus HCl minus chromium, Cl and OH. So what do we do? Yes, this OH is going to bring away a proton from here. Only one proton remains with this. One double bond is obtained. This is what you're going to get. Aldehyde. So this is the correct answer. Moving onwards, the major product formed in the following given reactions is, now you see, here you are having a Lewis acid PHCHO in the presence of a Lewis acid. What is the type of reaction that we must get? तो ये जो reaction है guys, यहाँ पे OTF present है. OTF is usually a good leaving group, but यहाँ थोड़ा role different है इसका. Let's say I'm writing this as the R group. Okay, let's say like this. Now what should happen? The reaction in the presence of Lewis acid, the carbonyl carbon becomes so electron deficient that it is going to be attacked by, let's say, directly attack this electron pair, attack this bond over here such that the bond opens up in the presence of a Lewis acid. So PHCOH, one more hydrogen, and the double bond and the R, just like that. So the double bond and the R are going to add to this carbonyl so that you get this molecule. So fourth is the correct answer. Moving onwards, the intermediate A and the major product B found in the given reaction. अब ये इस type के question पहले आ चुके हैं exam में, okay? And you must have realized that there are a lot of repetitive questions in this paper, okay? So in the presence of heat, the Br minus is eliminating. ये वाला bond open हो जाएगा. And what does that give you? बस उसी के बारे में जानना है. What does that give you? You have to be careful. बस ये देखो. It gives you a carbocation on this particular carbon. So A is the carbocation and B is where the Br minus attacks back. Alright, it's not going to attack over here क्योंकि carbocation तो इधर है. Okay, so this is what you are getting. This is wrong, this is wrong. ये भी wrong है तो इसका आंसर तो 3 ही निकला. ये बहुत ज़्यादा easy question है because the options are making it easier. Okay. Alright, another good question. The correct set of reagents required to convert ethyl benzoate to ethyl benzene. Now, what is ethyl benzoate, guys? Ethyl benzoate in this way, and this has to be converted to something like this, CH2, CH3, okay? What are we going to do? If we take excess of methyl magnesium iodide, then this is going to end up giving you this particular alcohol, a 3-degree alcohol. Okay, you are not going to get ethyl benzene. So this option is wrong. Neither can you use Grignard with excess of ethyl, right? We don't want that. It's going to end up giving you the tertiary alcohol. However, if we take this complex, the titanium one, so basically it is nothing different. It is the same reagent. However, only a little bit different because here only you're going to get limited number of methyl transfers. All right, and let's say only one Me minus is going to be attacking over here such that you can replace this ethoxy group and get a carbonyl, get a ketone over here in such a way. If you once get a ketone and do the hydrolysis, then the ketone is going to be protected by 1,2-ethane diol. All right, and that ketone is protected in this way by 1,2-ethane diol. Oh, sorry, dithiol. This is the major difference. This is the diol, and the third option is dithiol. Why that is a major difference? That is sulfur over here. Okay, there is going to be sulfur. Why is that the major difference? Because you see, now you can easily remove, you can easily cut these bonds, desulfurization in the presence of Raney nickel. It's a beautiful application of Raney nickel. It does desulfurization. If you are using mercury and water, it is again going to give you back the ketone. But if you are doing, if you are taking Raney nickel, that completely removes the sulfur bonds, and in place of that, you will have 2 hydrogens. So this is a simple 1,2-ethane diol which is not going to work, and this reagent is strange because it is neither the Wolff-Kishner reduction, you require a base for that, so this is not happening. Third one is the correct answer, okay? So you're only transferring limited number of methyl so that you get the ketone, then the protection by dithiol followed by desulfurization to get this molecule. Okay. Now, a very important question and directly asked from Caruthers. So I have emphasized enough about this question in the classes. Okay. So what do we see over here? We see something like this. Let's draw the molecule in this particular way or in this way such that this is the triplet group, good leaving group. I write the double bond over here and then I write the SiMe3 on this particular side, for example. Okay, or one more way of writing the same molecule. We will write the double bond over here. We'll write the double bond over here and we will write the SiMe3 like this. Yes, why have I written this molecule in this way? Because you see in the presence of ZnCl2, which is a Lewis acid, the OTF is going to leave and you will get this kind of a allylic carbocation with a beta stylyl group like this. And then it can do a cycloaddition reaction. Now, which kind of cycloaddition reaction it is? See, it is going to be 4 plus 3 kind of cycloaddition reaction. That is, you are going to have to attack in this way. All right, and there's going to be a carbocation on this center. So it's going to give you a 7-membered ring. It is not a strange reaction. It has been discussed in the Claydon, in Caruthers, in both of the books it is present. All right, the bonds are too long. Okay, but yes, you will have a positive charge over here. And now, yes, and now because the chloride is present, it is going to attack and eliminate the silicon, which is going to give you a double bond over here. So this is your correct answer, option number 4. It's a 4 plus 3 cycloaddition, very important example, directly from the books. Now a yellow colored complex P upon addition of aqueous HNO3 forms a very pale violet colored complex Q. Alright, so a yellow colored complex P on addition of aqueous HNO3. Whenever a statement kind of question is given, just write in a simplified way so that it's easy to solve. Gives you a very pale violet colored complex. So I'll write pale violet. Okay, and once I'm adding NaCl to the Q, it again forms a yellow colored complex R. So the question is asking what is PQR, which is consistent with the above knowledge. Now, first thing, if you're adding water, see, let's try out the first example. We always start with the first one. So in the first example, I see that there is an OH minus, and if I'm providing acid to it, it might become OH2, which is going to add to this ligand. Then it becomes a completely centrosymmetric molecule, and Fe3 plus, iron Fe3 plus is D5, high spin. So this Q is going to be Laporte forbidden and spin forbidden. The DD transition is forbidden and that's why it's very pale violet. So it seems correct. If I apply the same knowledge in other options of Q, it is not so because this is going to give you color. It is not centrosymmetric. This is also almost correct. All right, and the second one is not correct because here it is 2 plus, which is going to be D6. It is going to be spin allowed. So 2 and 3 are absolutely wrong. I have the same option in 4. We'll check that as well. Okay. Now, it should also be yellow colored. So I doubt that ammonia complex is going to be yellow colored, but still let's move onwards and check what is the other information. If I'm adding NaCl, it is going to give us a yellow complex. Now, what is possible? In this, if I'm adding NaCl, what is possible? It might replace one of the water molecules. Yes, it cannot replace 3 water molecules at once. So this is less possible as compared to this one because here also we are usually just replacing one ligand. That's why option number 1 makes more sense as compared to 4. So 1 is the correct answer. Next, was an utmost easy question. I cannot say how easy this was. A tungsten which is present in +6 oxidation state in all of these. So the oxidation state is +6 in all of these, but still the d electrons are changing because the number of charges on this. So in the WCl6, where there is no charge, this is D0 complex because tungsten has D0 electrons, but the total valence electrons are going to be 6 and 6, 12. So one is going to match with C, which is going to match with X. 1, C and X are matching. Okay. Then next, because the oxidation state is now +5, because there is a negative charge over here, so I will write this oxidation state is +5, so it will have 1 electron. Then we have WCl6 minus, then this is going to be +4, so it's going to have the 2 electrons, so on and so forth. So this is going to have 1 electron and it's becoming 13. This is going to have 2 electron, it becomes 14. So 1 is the correct answer again. Okay. Moving onwards, the major product formed in the given reaction is. Now, when we react this kind of a ruthenium reagent, ruthenium in the presence of NaIO4 is going to be behaving as a strong oxidizing agent. What does it do? First of all, it does cyclization. So, it is going to do this kind of a cyclization with the, pi bond like this, and then it's going to break apart in such a way that it's going to give you 1,2-diketone. This is how the oxidation takes place, and our answer is option number 4. Next very important question, major product formed in the given reaction is. Now you see, 2 equivalents of indole is used along with aldehyde and a little bit of acid. So the question is only based on electrophilic attack. So let's say this is the electrophile in the presence of acid. It's going to be like this, protonated. Now, which is the position from which indole is going to attack? Absolutely, it is the third position. It is this position which is most nucleophilic. So it cannot be option number 2. Let's say both the indoles are attacking from the third position, is going to be more favored as compared to any other. So 2 is not possible. Second position से attack नहीं हो सकता है. 1, 3 and 1 directly attacking over this. No, we don't have a base, so this proton is not removed. ये तो बिल्कुल नहीं हो सकता है. And in the same way, again, 1, 2 and 1, 3 is also not possible. Either is both 2, either is both 3. 3 is more preferred, so 1 is the correct answer. Next good question. Now this is, yes, a tricky one. You are having -78 degrees centigrade. 2 equivalents of tertiary butyl chloride and AlCl3. So what do you get? You get this kind of a carbocation. And it's -78 degrees centigrade. What does that mean? You can have more than one possibilities, but this is the kinetic product that we are looking at. That is the you can get the more stable, less stable, right? What is the possibility? See, in this molecule, in this bulky molecule, this position is the one which is the least hindered position. All right, it is the least hindered position that you can get for a bulky electrophile like this, and that's why 2 is going to be more favored. If we check out option number 4, they are absolutely not going to be possible. Option number 1 also is going to cause the buttressing effect, and directly it is not going to be, very stable because it is forcing the molecule to be stuck. What about option number 3? For option number 3, it is usually the 5 and 8 position which is going to give you the electrophilic aromatic substitution. But here, this one is going to give you a better intermediate, stable intermediate, and that's why this is the correct answer, option number 2. You can check it out once. All right. Now, next very easy question. Among SF4, ClO4 minus, FClO3, IF4 positive, the number of species having the seesaw shape. Now, these kind of questions have been repeated many years. Mostly in the VSEPR, the type of shape and structure is asked. So SF4 has one lone pair and it is seesaw. ClO4 is tetrahedral. This is also tetrahedral IF4 plus. When the positive charge is present on iodine, it will have the same number of electrons as sulfur or oxygen. So this will again give you a seesaw structure. Questions are, so again a very repeated question, and this is repeated from the very old CSIR net paper. All right, around let's say June 2015 or 14, somewhere like that. That there are two bulky groups which are given over here on the above position. These are two bulky groups, and definitely there is a double bond over here. Now, when we are directly reacting with metachloroperbenzoic acid, it's going to give you epoxidation from below the plane. So this is going to give you below epoxidation. And when we are taking the NBS, NBS is first going to give you bromination below the plane. All right, NBS is going to give you a bromonium ion. All right, that's going to give you this kind of a bromonium ion formation from below the plane. Okay, like this. Now, next thing is you are having a base in the next step. The base is going to attack on any one of these positions, let's say, but it will attack from above. All right, so if there is a OH minus, it's going to take away a proton of the oxygen, and now you have the Br minus, Br, to which it is going to attack in such a way, and that gives you the epoxide on the more hindered side. That is, gives you the epoxide over here. So that's why 2 is the correct answer. You get A over here and you get B over here like this. Okay. Next one, the correct order of second ionization enthalpies is. So first ionization enthalpy will give you, let's talk about all of these. Boron, carbon, nitrogen and beryllium. What is the electronic configuration? This is 2s2 2p1, 2s2 2p2, 2s2 2p3, and this is 2s2. So when we are talking about beryllium positive, let's talk about the first ionization enthalpy. That gives you 2s2 only for boron positive. That gives you 2s2 2p1 for carbon positive, and for nitrogen it is going to be 2s2 2p2 for N positive, and for beryllium it's going to be beryllium plus is 2s1 now. Okay, but here we are talking about second ionization enthalpies. So once again, who is going to have the most let's say who is going to be having the maximum energy? Where is the maximum energy required? I guess nitrogen, being more electronegative and having a smaller size as compared to all the others, because while we are moving from beryllium, boron, carbon to nitrogen, this is most electronegative and most the smallest in size. So removing an electron from here is going to be more difficult as compared to 2s2. Otherwise we would say ki ha 2s2 hai, it is going to be very difficult to remove this electron. But nitrogen being smallest in size and most electronegative, we write nitrogen before boron, then carbon, and lastly beryllium. All right, so this is going to be the correct answer. Next, another repeated question in your CSR exam this time. So see, this has been asked so many times, that there is a anionic complex of manganese which is going to attack on the allylic chloride. So C3H5 is allylic chloride. If it has a negative charge, it's going to attack over here, replace the Cl minus. That gives you eta 1 complex of this. Why eta 1? Because this is now an 18 electron system. Okay, but the removal, heat or light removal of carbonyl is going to give you MnCO whole 4, like this species, like this complex, which is going to be a 16 electron complex. And now the allylic group is going to change its hapticity such that it has become a 3 electron donor. And now if you count the electrons, 3 plus 7 plus 8, that gives you 18 electron species. Okay, so your answer is going to be eta 1C3H5 MnCO5 is present in P, and after removal of a carbonyl where it becomes CO4, it's going to become eta 3. So fourth one is the correct answer. Okay, moving onwards, very beautiful question. This is major product formed in the given reaction. अब ये देखो, ये बहुत easy question है that Cl is going to be driven away, it's going to be taken away by silver, because silver is present. What will happen? You are going to be left with the nitrogen. अब क्या कर सकते हैं हम ज्यादा से ज्यादा नाइट्रोजन के पास में, या तो हम एक हाइड्रोजन ट्रांसफर कर सकते हैं ऑन दी नाइट्रोजन, or we can shift this bond over to nitrogen. And if we do so, let's say हमने bond ही shift कर दिया नाइट्रोजन के ऊपर, then you get something like this, and you get a positive charge on this particular carbon over here. Either we can do this, but there is a problem. What is the problem? The Cl in the question is pointing downwards. So we don't do this possibility. We do one more possibility, that okay, the Cl is being taken away by silver. ये वाला जो bond है जो trans में है, let's transfer this and let's see what happens. Alright, let's transfer this bond directly over nitrogen. We are going to be left with the carbocation over here. Okay. Now what? Do we have an option? Do we have such an option कि यहाँ पे अब methoxy attack कर लेगा? Yes, we do. And the option is option number 2. Okay. So basically, ये वाला जो ring है, this one, this larger, the one having 2 carbon atoms, it is written over here, and this one is written on the top. That's the only difference. This is your correct answer. Okay, that is, we are going to shift the bond which is trans to the Cl which is given in the question. Okay, next very good and repeated question. ये सारे 2015-14 के आसपास के पेपर के question repeat हो गए हैं. In the given reaction, CH2, this one basically is a synthetic equivalent of. Now when you are reacting the diene with this particular compound, it's going to first of all give you something like this. Okay, or I should write the double bond over here, and I write the pH over here. Then in the presence of heat, it's going to cause syn pyrolytic elimination, that gives you this compound. So this is the reaction mechanism first of all. Now you will obtain the same compound, you will get the same compound if we have taken an acetylene molecule, because it is going to give you 2 pi bonds on the 2 different sides of this. So ethyne is the correct answer, and this is a repeated question, guys. Yes, the number of unpaired electrons in Cp2Fe, Cp2Ni and Cp2Co complexes are. So when we are talking about ferrocene, it is basically asking you about the number of electrons or the electronic configuration, कि हमें electrons कैसे fill करने हैं. Okay, so let's do this. For the ferrocene, you have 18 electrons. And for nickelocene you have 20 electrons, and for cobaltocene you have 19 electron. इसके ऊपर पहले भी question आ चुका है, but that was on the bond order or where the extra unpaired electrons are going to go. ठीक है, but now this is how you're going to fill the electrons on ferrocene. What are the energy levels? This is basically considered E2G, which is a combination of dx square minus y square and dxy. Alright, this is going to be A1-G, which is a combination, which is basically the dz square, and the upper one, these two, the most unstable one, are dxz and dyz, which form the antibonding E1G star. Okay, so this is what you have to see once. और अभी हमें ये देखना है कि इलेक्ट्रॉन कैसे फिल होंगे. 18 electrons. So these electrons, I am only considering the orbitals for the iron or the metal, क्योंकि metal के जो 5 orbitals होते हैं वो कहाँ जाएंगे, that is what we see. Other than that, we don't see for the ligands. So Cp2 is going to give you 10 electrons in each of these, और बाकी के जो बचे हुए electrons है वो कहाँ से आ रहे हैं, metal से आ रहे हैं. ठीक है. So for the iron, which is a D6 system iron is going to give you 6 electrons like this. For nickel, which is going to be your D8 system, alright, nickel 2+, is a D8 system. So it's going to give you electrons in this way, 6 electrons and 2 more electrons in the anti-bonding. Or cobalt kya hai? Cobalt 2 plus is a D7 system. So 1, 2, 3, 4, 5, 6 and 7. So the question is asking number of unpaired electron. Kitne hai? 0, 2 and 1. So this is the correct answer. Transfer. Now another question based on the electron transfer, मतलब कि जो हमें inner and outer electron transfer processes पढ़नी होती है, based on that this question is very simple question. पूरा sentence में बना दिया, इससे ज़्यादा easy कुछ हो ही नहीं सकता. ठीक है. An outer sphere mechanism involves electron transfer from reductant to oxidant with the coordination shells or spheres of each staying intact. Absolutely, they stay intact because there is no bridging ligand, there is no change in the ligand. All right, after hydrolysis, कोई ligand change नहीं होता है, वैसे के वैसे रहते हैं. So the coordination sphere is going to stay intact. A is correct. Yes. Inner sphere mechanism में the reductant and oxidant share a ligand in their inner or primary coordination sphere which assists in the electron being transferred. Absolutely. This is also correct because यहाँ पे हमें क्या चाहिए? Bridging ligand चाहिए. Yes. In the inner sphere mechanism, an oxidant possesses at least one ligand capable of being binding simultaneously to the two metals. All right, this is also correct क्योंकि जो oxidant होता है it should have the bridging ligand. Inner sphere में ligands of reductant are substitutionally inert. No, ये आपको जानना जरूरी है that oxidant should be substitutionally inert. However, reductant should not be. So till C it is correct. So A, B and C are the correct answers. ये आप कोई भी coordination की book से पढ़ सकते हो. It is given in the book what are the prerequisites of outer sphere and the inner sphere mechanism. You will get it directly. All right, next important question is ये देखो major products of the given reaction. So you are having this 2,3-dihydropyran in this way. What does it do? Protects the alcohol. So if let's say we are protecting the alcohol in this way. अब ये alcohol कैसा है? It is already a chiral alcohol. There is already one chiral center, and after this bond has taken form, this is also become a chiral center. अब दो chiral center जब हो जाते हैं एक molecule में, and when one of them remains fixed and the other one can change, that is going to give you a pair of diastereomers. For example, I'm saying ये तो same है. Okay, let's say it is R or S, you can find it out. Let's say this is R, लेकिन ये R और S दोनों हो सकता है. So you have a combination of RR, you have a combination of RS. So what is the relationship between them? Diastereomers. Okay. Yes. Next, very good question. The given reaction proceeds via. Now I have discussed this question just few days before in the plus classes. ये बहुत ही अच्छा question है कि direct reaction हम नहीं कर सकते ना इसका. We cannot do a direct Diels-Alder reaction of this and this because there is no diene. So what we do is we do a 1,5. We do a 1,5 hydrogen shift in this way such that a diene is created. Alright, यहाँ पे आ गया है hydrogen such that a diene is created and now it can react with the maleic anhydride in this way. So this now gives you a Diels-Alder reaction that is going to give you this particular product. So it is not a 1,3 hydrogen shift, it is a 1,5 hydrogen shift followed by 4+2 cycloaddition. और ये बहुत ही अच्छा और easy question है. Alright guys, so this next question is very important and it has been creating a lot of confusion among students. Now whenever you see the CBS catalyst, it is basically doing psi-facial reduction, isn't it? It is going to transfer the hydrogen on the psi face. So usually when we consider the short trick, we usually say that the largest group should be on the left bottom like this. All right, and the small group should be over here, such that we are automatically going to get one way of representation, and we say that the hydride is going to attack over here like this. Okay, so it is 1, 2 and 3. Yeah, and this is how you get the psi face on the top. You get the psi face on the top and the hydride is going to attack from above. So this is why you write the molecule in such a way so that you always follow one method and you don't get confused. But it's not necessary that in the exam it's always given in the same method. Now a lot of students are confused about which one is the bigger group. किसको priority ज़्यादा देंगे? Obviously CCl3 को, because when you find out the priority it is like this: 1, 2 and 3. So you see it is the re face on the top. Re and psi face में it is the re face on the top. So top पे अगर re face है, so we cannot transfer the H minus from the top. The bottom face is absolutely going to be the psi face. तो इसलिए जो hydride attack होगा, that is going to be from the bottom. Okay, so this is wrong, this could be correct, and this is wrong and this could be correct. Okay, now moving onwards, what is the next reaction? In the presence of a base NaN3. So what is the OH minus going to do? The OH minus is absolutely going to cause hydrolysis of the CCl3, okay, and it's going to produce the carboxylic acid. All right, what next? Next is, in the presence of a base, OH is also a good leaving group, so the azide is going to do an SN2 attack like this so that the OH minus leaves. This is your product. Answer is option number 4. Okay, and also if let's say OH was not present over here, if there was some Cl and if you provide AgNO3 or something, then you could do NGP with this carboxylic acid group. But here there is less possibility of that because the azide is going to attack directly, and this is a simple SN2 reaction. You don't have any NGP possibility. Next thing, major product formed in the given reaction. So again guys, you have 0.95 equivalent of KOH, that is almost 1 equivalent of OH minus. What is that OH minus going to do? You have methanol, you have water, but there is one thing. Look at the stereochemistry of these two groups. This ester is trans, but these two groups are pointing below. So what can we do with that? Let's say, there is a question which comes like this: which of the following ester is going to be hydrolyzed easily? Yeah, this is going to be hydrolyzed easily because the OH is going to attack and form a lactone first. Okay, so this OH is going to help in the formation of a lactone like this, and then the OH minus is going to attack over here and it gives you the hydrolysis. So this is going to be hydrolyzed better. So that's why the answer is option number A and not B. All right. And these examples, this is not going to happen absolutely because you don't have methyl iodide. So 2 and 3 don't make sense. And this is not going to be hydrolyzed before this one. So 1 is the correct answer. Next, major product formed in the given reaction is. Now this is a simple question. You are just going to do conjugate addition in this way. Acetate is a good leaving group. You could also write that this methyl can attack directly on this particular carbon, but as long as you have this Gilman's reagent and you have a double bond, it is absolutely going to favor the attack, the conjugate attack like this, and you're going to get this one as your correct answer. This is not 4, it's going to be 3 only. Okay, next good question. Consider the following reaction scheme and related statements. BRF undergoes disproportionation to give you BR2 and X, T-shaped geometry. Now it's a very simple question for those who have studied a little bit of main group and solvent system. Okay, so BRF, let's say, reacts with another BRF to give you 2 of the bromines. All right, then what is going to happen? Are we having two fluorine, or let's say 2 atoms of fluorine? No. We will have BrF3. All right, so for that, let's say we have to use more moles of bromine. Let's say I'm using 3. What happens then? Yeah, 3 of the fluorines come over here, or let's say I'm using 2 of the 2 of them. Yes, then I have total 3 bromines, out of which 2 eliminate to give bromine gas, and one of them forms the BrF3. Okay. So this is a disproportionation reaction this way. And BRF3, absolutely, you know, it has T-shaped geometry because it's going to have two lone pairs and trigonal bipyramidal system. It's going to be like this. Okay. Now X undergoes self-ionization. This is a reaction from solvent system. Okay, so BRF3 is going to undergo self-ionization to give you BRF2 positive and BRF4 negative. Okay, this is the cation and this is the anion. So this is Y and this is Z. Alright, now X, Y and Z have the same number of lone pair of electrons. Let's check. Here it has only two lone pair because this is just like water. It's going to be a bent system. So it is just like water, two lone pairs. This one is going to have how many lone pair? You have BRF4 negative. It will have again two lone pairs. Yes. What about BRF? It is going to have three lone pairs. So let's check. 7. Yeah, it is going to have three lone pairs. Alright, so A should not be correct. Y has a bent shape. Y does has a it has a bent shape. Yes, just like water, as I said. This is true. Z is sp3 hybridized and has tetrahedral shape. Z is the anion. Alright, it is BrF4 negative, but it is not going to have a tetrahedral shape because it is going to be having 8 electrons. It's going to be square planar. So C is wrong. X is used as a non-aqueous solvent. It is BRF3 is used as a non-aqueous solvent. So till now we had found A, B and D. Okay, let's check A as well because I think that we have to recount the number of electrons. This is X, which is BRF3. It has two. Okay, yes. So this is X, BRF3. Y is this, 2 again, and Z is this. So yeah, this is correct. A, B, and D is the correct answer. I just wrongly considered this to be the X. It has three lone pairs. Okay, yes. Moving onwards. Okay. So, alright guys, so these are the number of questions that we have done today, and I just hope that it has helped you, and also informing you about the type of, the help of PYQs in this paper. Even for those students who have given the examination, they have realized कि PYQ solve करने से बहुत ज़्यादा help हो गई है. There are a lot of, if not exactly common, but similar questions that you have got from the previous years. Okay, so yeah, please solve the previous year questions of both CSIR Net and GATE. And I have created a playlist for CSIR Net question, for GATE as well as for TIFR questions. So please go through that TIFR question ki playlist. And if you are liking this video, please like this. I usually don't insist a lot on liking, but yeah, a video में एक बार तो बोल ही सकते हैं. So please like my video and please share it with your friends. I'll see you soon in another one.